Okay, let's say the average time spent sleeping in hours for a group of medical residents at a hospital can be approximated by a normal distribution, as shown below. We're given the mean is 5.4, so we could kind of go ahead and put that right down the middle, 5.4, and the standard deviation is 1.3 hours. What is the shortest time spent sleeping that would still replace a resident in the top 5%? So in other words, this would be the top 5%. So we're looking for that X value right there. All right, so either 5% or we know our Z table is in 4 decimals. However, remember you read from the bottom up to that value. So what we're really going to be looking for in our table is the value closest to 9.500. So let's look. When I look, I see 0.9495 and 0.9505 are the same distance. And this is one of the unusual ones. Typically they're not, and you just pick the closest one. So since they're the same distance, and that would be a Z of 1.64 and a Z of 1.65, you probably would be fine using either one, but typically what they do is they average 1.64 plus 1.65 and then divide by 2. And then what they get is 1.645. So over here on the side, what I'm doing is I have my Z formula equals X minus mu over the standard deviation. We just said that the Z value is 1. Either 64, either 65, or 1.645 if you averaged it. Sorry, that's an ugly 4, but it's a 4. And then they give me the mean and the standard deviation. And now you just do that crazy stuff those algebra kids are doing, right? And you multiply both sides by 1.3. So I'm just going to solve this for X. And then you end up with adding 5.4 to both sides. And when you do that, you should get 7.54. So that's the actual X value right there, 7.54. Okay, let's look at another one. So here it says, between what two values does the middle 50% of the time lie? So the middle 50% would be probably, you know, somewhere about here. My good straight lines there and here. And we still have our mean of 5.4. So this in here would be the middle 50%. Well, remember that this entire curve has to add to 1. So that means there's 50% left over, right? Well, because this curve is symmetric, and that's very important, this problem you're going to see why that's important, is half of it has to be on this end, in other words, 25%, and the other half on this end, 25%. All right, so we're once again going to be solving for these X values, a lower X and an upper X. So looking in our table, we're going to be looking for the X value closest to 0.2500. And we're going to be looking up the, I think I said X value, the Z value closest to what? What would this one be? Well, 25% plus 50%. So that's going to be 0.7500. So those are the two Z values we want to look. We want to find the Z value that is closest to 0.2500 and 0.7500. So if I look in the table, I see the closest value to that area, that probability of 0.2500 is negative 0.67. And if you really understand how this curve is symmetric, you already know the upper is 0.67. If you don't understand that yet, you look up in the table and you find the value closest to 0.7500, and you see it's the 0.67. All right, so those are my Z values. Go back, get me another color here. All right, so that means I have my lower value, which is negative 0.67 equals x minus the mean, and I meant to go ahead and put what the mean was, 5.4, and then divide it by 1.3. And using the same techniques as the other, so negative 0.67 times 1.3 plus 5.4, you should get the x value of 4.53. And then we do the same thing, x minus 5.4 over 1.3. And solving that for x, you should get 6.27 for those x values. So it's important that you understand this curve is symmetric. So that way, if you have a lower 25%, the Z value will be the same as the upper 25%, just the lower will be negative and the upper will be positive.